Okay, let's continue with some more homework problem from 5.7. This is the integral of x minus 3 over x squared plus 1. U substitution is not going to work. Our u value initially will be 2x, and that's not going to cancel out with the numerator. However, there's only two terms in the numerator, so we could actually split this up into two separate terms. Of course, we do need to keep this, treat this like one. We can't split this up. This has to be treated like one term in the denominator. So think of this as the integral of x minus 3 over maybe a u value. So I can split this up into two separate fractions, and if I do that, then maybe I can find the appropriate rule for if I split this up into two smaller problems. So I'm going to write this as the integral of x over x squared plus 1 minus the integral of 3 over x squared plus 1. Now these two fractions, if we were to combine these two fractions together, it'll simply be x minus 3 over x squared plus 1. But if we split this up, we can see that we have an easier time finding the rules for each of these smaller portions. So here, if we let the u value be the denominator, we see that our derivative 2x will cancel out with this x. And this matches up nicely with the arctangent rule, because the u could be x, the a could be 1, and that's going to be matched up nicely with du over a squared plus, or u squared plus a squared. So let's treat this like two separate problems and go through this. Our u value on the left side is x squared plus 1. Our derivative is 2x. dx is du over 2x. We make our substitutions. The x stays. Denominator becomes u. dx gets replaced with du over 2x. The x is canceled out. The 2 is a coefficient, gets pulled out in front. 1/2 times the integral of 1 over u du. We have a nice rule for this, which is natural log of absolute value of u. So that's exactly what we have, 1/2 natural log of absolute value of u plus c. And then 1/2 natural log of the absolute value of x squared plus 1 plus c. Notice again, just as a reminder, whenever you find your indefinite integral, once you apply the rule, once you apply the antiderivative rule, the integral notation drops out, and also your derivative, your du, drops out as well. Second portion here, we said that this matches up nicely with the arctangent rule. So we need the parentheses to show up, something squared, and then parentheses squared. So the first here, x is simply just going to be x squared will become just x inside. 1 is simply going to be 1 unchanged. Our u value is x, our a value is 1. Our derivative will simply just be dx equals du. So no coefficients will be added. We just have this 3 that's coming up from the original problem, so I can just pull that 3 out. So I have negative 3 integral of du over a squared plus u squared. This matches up nicely with our arctangent rule. So we simply apply that, which is 1 over a arctangent of u over a plus c. And then this negative 3 is a coefficient that's outside the rule that we have to include. So combine all this, we get negative 3 arctangent of x plus c. And then in front of it, the first solution that we found was 1/2 natural log of the absolute value of x squared plus 1. Okay, 19. We have the integral of x plus 5 over the square root of 9 minus x minus 3 quantity squared. Okay. It may not be apparent, but arcsine alone, even though this looks like arcsine because we have the square root, we have the a squared, or the associated value with a being the positive, followed by minus, and followed by the u value, which we know is always going to include the variable. Arcsine rule alone will not be sufficient because of the x variable that's sitting up in the numerator. Okay, and it's not going to initially cancel out. However, let's just go ahead and go through u substitution for the denominator, for what's inside the radical, and see what we have left, and see if we can use that to help us decide how we want to split up the equation. Okay. So we're going to let the u value be 9 minus parentheses x minus 3 quantity squared. We go through our derivative. 9 is a constant. We'll drop down to 0. We can go through chain rule here. Bring down the 2 in front. Keep the parentheses. Subtract 1 from the exponent. multiplied by the inner function's derivative. So x minus 3 becomes, the derivative of x minus 3 is 1. And this reduces to be negative 2 x minus 3. We solve for dx. We get du over negative 2 parentheses x minus 3. So what we need is we need at least this x minus 3 in the numerator of our problem so that we can allow us to cancel out. Okay. However, that's not what we have. We have x plus 5. But if we can rewrite this expression so that we have this portion to cancel out, then we can split up into, then we can have the leftover portion as a separate problem, and then we can just find the rule for that. So x plus 5 is equal to, now we need the x minus 3. This 2, it's okay to not match this 2 because we see that coefficients can be in front. We just need to have either the variable or whatever's attached to the variable, either through a plus or minus sign, that needs to just cancel out cleanly. So we want the x minus 3, so we want the x minus 3 to cancel out, so I'm going to just have the numerator being x minus 3. However, x minus 3 is not the same thing as x plus 5. We need to maintain balance, so we can't change the problem. But if I have x minus 3 plus 8, negative 3 plus 8 does equal to positive 5, but now I'm just going to have this plus 8 to be a separate problem, right? Anytime I have a plus or minus, I can treat it like two separate problems. So this first portion will be u substitution, and this portion is actually going to match up nicely with the arc-sine rule. So u substitution, we already went through the derivative process, so we know dx is du over negative 2 parentheses x minus 3. We see that this negative 2 not matching up with the top is okay, because at least the x minus 3 cancels out. We can just pull that negative 1/2 and we can continue with the problem. Okay, it's not going to affect our ability to continue with our u substitution or with our integral rule. Now, square root of u, this is not natural log rule. All right? Natural log only works if it's 1 over u to the first power, but this is u to the 1/2 power in the denominator, so this is a power rule problem. But we can't just leave this u to the 1/2 in the denominator and apply power rule. Remember, power rule needs variables sitting up in the numerator, so I need to bring this up top to be u to the negative 1/2. Now I'm set up so I can use a power rule. Coefficient stays. Negative 1/2 plus 1 is 1/2 divided by that new exponent. Clean this up. This 1/2 can be flipped to be 2, so this cancels out to be negative 1. So we get negative 1 u to the 1/2, and then our u value is 9 minus x minus 3 quantity squared. Okay, so that's the first portion. The second portion, we see that this matches up nicely with the arc-sine rule, with the a squared coming first, the u squared coming next. So if we want we need the parentheses to show up with the exponents 2 to be in place so that we can match up with our rule nicely. So our a value has to be 3 because 9 has to be represented as something squared, so we'll put a 3 inside. X minus 3 is already squared, so we leave that there. Our a value is 3. Our u value is x minus 3, so our derivative for x minus 3 is 1. Our dx equals du. Go ahead and pull that 8 out in front. Dx gets replaced with du. And we have our a squared and our u squared in place. This matches up nicely with our arc-sine rule. Arc-sine rule is, the integral is arc-sine times arc-sine of u over a plus c. And the 8 is coefficient, so we need to have that in front. And then we have the second portion, we have our first portion, so we combine all that with the plus c, and that is our solution.